Hey everybody, one of my students in astronomy sent me this picture from their Snapple cap today, and he thought it was cool because it's like, hey, I'm learning about astronomy and this is what my Snapple cap. So apparently Snapple has these real facts, in air quotes, real facts underneath their caps. This one says a full moon is 9 times brighter than a half moon. And as an astronomy professor, I'm like, wait a minute, this doesn't make any sense. First of all, there's no such thing as a half moon, right? There are quarter moons where the moon is half illuminated, but we don't call those half moons. And you might be like, well, I call them half moons. And I'll be like, well, here's an astronomy textbook. And let's go to the index. And if you look through the index, you will not find the term half moon anywhere. It goes straight from Hale-Bopp to half-life of isotopes to Asaph Hall. But if you switch over to Q, you will definitely find quarter moon, the quarter moon phase. And in fact, if I go to the section way at the beginning of the book here on moon phases, I can even show you the picture that shows all the moon phases and has all the terms in bold, and you will not find half moon anywhere. So that's already one thing I think is wrong about this real fact, is there's no such thing as a half moon. The other thing I'm really concerned about is this idea that the full moon would be 9 times brighter. First of all, in astronomy, talking about brightness is kind of complicated, and it sort of doesn't make any sense that if half the moon is illuminated, it would be a ninth of the brightness, right? Let's just take this drawing here and let's check it out. I think a simple geometric argument would suggest a different answer. So let's just look at, okay, here's the moon. It is the shape approximately of a Snapple cap. And if I half illuminated it, right, and essentially I could make a really simplifying assumption, which is to say that the moon is uniform brightness. It's like a light where it's all about the same brightness. And so if half of it is illuminated and half of it is dark, okay, then I would assume naturally that it's half the brightness because it's half the area, right? If I would just think that the brightness goes as the area we see. So if I have half the area, I would assume it's about half the brightness. I feel like that's probably a pretty good assumption, but we can actually check this even better. I can go to Stellarium, our favorite web planetarium software, and I can actually zoom in on the moon and check its actual brightness, its actual magnitude. So let's do that. When the moon has a 50% phase, which we call a quarter moon, the magnitude is negative 11.95. All right, so I'm going to write this. There's going to be some math here, people. We're going to figure this out. So the magnitude at quarter phase here is negative 11.95 magnitudes. You definitely cannot read my little quarter thing there. We'll call it little m because it's going to be, less bright. So then what is big M? What's the magnitude? Well, that's actually not proper astronomy. We'll call this magnitude Q, okay, for quarter, and magnitude F for full. So what is the magnitude of the moon when it's full? I got to change the date here a second and get it full. We're checking the phase over on the left-hand side. We're at 95% phase, 99%, and 100%. And what is it? It's 12.69 magnitudes. So in astronomy, we use this weirdo measurement tool, this unit called magnitudes. And the weird thing about magnitudes is they are a logarithmic scale. So the math is a little weird when you're comparing brightness. Still, I would think Snapple could get it right. Let's see if they did. They said it's a 9 times difference. The difference of magnitude is from 12.69 to 11.95. So let's just take that difference. In magnitudes, we can just subtract those two things. Now these are negative values, so the difference here, 12.69 minus 11.95, the difference is 0.74 magnitudes. All right? So I could say that M full minus M quarter is 0.74 magnitudes. Now, I know that that is not the same as 9 times difference in brightness. Because it's a logarithmic scale, what that means is, in practice, 1 magnitude is approximately the same as 2.5 times a change in brightness. That's kind of weird, but that is how the magnitude scale works. So it's definitely not 9 because it's less than 1 magnitude in difference. Let's figure out what it actually is using math, right? We estimated it should be about half. I mean, honestly, right? It's half the moon. So let's figure it out. You guys ready for some serious math? You can skip ahead if you don't want to see some serious math, but let's do it. Here's the actual equation for figuring out how magnitudes relate to a factor change in brightness. So what you would do, I'm just looking at my notes here. So I would take the difference in magnitudes, okay, M2 minus M1. That is equal to negative 2.512 times the logarithms, man. Remember learning that in high school and you're like, why am I ever learning logarithms? I'm never going to use this in my life. Well, here it is. B2 over B1. The brightness of the object over the brightness of the other object. So we have full moon is object 2, quarter moon is object 1. Okay, and Snapple's claiming this difference in brightness is 9. So really, this whole thing is what we're trying to figure out, this factor. They said it's 9 times, all right? Snapple, quote unquote, their real facts, quote unquote, is that it's 9 times. Let's call that the brightness factor, B factor. That's what we're trying to find. We can figure this out. We already figured out the difference in magnitude. That was 0.74. It's actually negative 0.74. Because if we're taking the full moon minus the quarter moon, it's more negative. So we went further negative. So this is negative 0.74 equals, we're almost done actually with the math. There's only one hard step left. 2.512 times the logarithm of B factor. B factor. All right, so we want to solve for B factor here. So the brightness factor. So I'm going to divide both sides by this negative 2.512. Okay, that'll cancel it out from this side, and I'll divide it over here. Now I need a calculator. I can't do that in my head. We're getting close. Calculator time. Whoa, calculator time. Here we go. So the negatives cancel out, and it's just 2.512. 0. Remember this now. Help me remember this because I got to write it down. 0.29458. 0.29458. Did I get it? 29458. Close enough. Okay. Equals the logarithm of B factor. So now I'm ready to solve for B factor. The question is, how do you undo a logarithm? Well, you have to raise both sides, put it in the exponent. 10 to the power of the logarithm makes the logarithm go away. 10 to the power, I got to do it to both sides. 10 to the power of 0.29458 will equal the B factor. So what is it? What is 10 to the power of that? Ooh, let's see if we can get this whole number here. If I copy it, we'll get it as close as we can. Okay, 10 to the power of, paste, enter, 1.97. Look at that, 2. The answer is 2. 1.97. That's how many times brighter it is. Son of a gun. So you mean to tell me that this quote-unquote Snapple real fact, the real fact, is that a full moon is 2 times brighter than a half moon? Who would have ever guessed? Who would have ever guessed? And really, it would have been, even if they got it right, it would have been maybe more interesting. What it should say is a full moon is 2 times brighter than a quarter moon. And if they actually said that, it still would have been interesting. But no, they got it wrong. So, now you know what we get to do. This is the best part. This is the best part. Now we get to send a note to Snapple. Snapple real facts and tell them that they're wrong. Explore Snapple's fun facts. Here we go. So we can search on the facts. Let's search on moon. And here we go. Boom. Let's do it on Twitter just to embarrass them if possible. Real fun fact. A full moon is 2 times brighter than a quarter moon. I'll add this video to it so that other people can see the video. All right. Thanks for sending that to me. If you see other interesting astronomy stuff, feel free to send it my way.